Okay, for this problem, we're talking about the standard normal distribution. So one thing you want to know about the standard normal distribution is everything under the curve, all the probability under this curve is equal to 1. So that's really important to understand. So if you're given a side, let's say that up to this point, the probability is 0.47. And you want to know, let's say your z-score here is negative 1 point, I'm just guessing here. Let's say your z-score is negative 1.2 and you want to know the probability that z is greater than negative 1.2. So the greater than side would be to the right of it. So how would you find out how much this side is? So what you can do is use the complement rule, so where you take 1 and subtract the side that you don't want to know to get the other side, because we know the sides add up to 1. So if I subtract out the side that I don't want included, that would give me the side that I need. So z is greater than negative 1.2 would equal 0.53. Just a little something to get you started when you're looking at these tables. So for this particular problem, how do you find the greater than side? So that is what I just showed you, where you have to find the less than side from the table and then subtract that from 1. So let's look up our table. All right, so the first table are your negative values. Your second table are your positive values. So greater than 1.45, so you go 1.4 and then look at this. This is 1.40, 1.41, 1.42, 1.43, 1.44, 1.45. So right here, 0.9265. So draw your picture. Here's 0. 1.45 would be somewhere over here. And then the less than side, we said was 0.9265. So the less than side, all of this right here is 0.9265. So to find our side, we would say 1 minus, because we want the greater than side, 1 minus 0.9265. So when you do that, you get 0.0735, which is what the answer is. Now, the next one you would do the same way, greater than negative 0.50. So here's 0. Negative 0.50, negatives are on the left side. Okay, so we want greater than. So first we have to look at the table. The first table is the negatives, and we're looking at negative 0.50, so that's 0.3085. So this is 0.3085. So to find the opposite side, we would say 1 minus 0.3085. So the answer would be 0.6915. So anytime you're finding the greater than side, you have to subtract it from 1. Okay, so for the next one, we're looking at the probability that the z-score, is in between these two numbers. So this one is has a little bit more work to it. So first, let's draw our curve here. And then let's look at our numbers. We have negative 1.58 and negative 0.56. So here's 0. Negative 0.56, let's say somewhere right here. And then negative 1.58 here. So first, we're going to look at the probabilities of both of these numbers, and we're going to write those probabilities down. So let's look up negative 1.58 first. So negative 1.50, 1, 2, 3, 4, 5, 6, 7, 8. So 0.0571. So the probability from here to here is 0.0571. And then the probability of negative 0.56, 50, 1, 2, 3, 4, 5, 6.2877. So the probability from here all the way up to this point, I forgot what I said that quick, 0.56, 0.2877. So from here all the way to here is 0.2877. So to find the probability that we want, which is in between, you're going to subtract out the probability of the whole all the way up to 0.56. You're going to use it and subtract out. We want that number, but we do not want the probability below it. So we're going to subtract that out, and that will give us the probability that we want. So take the probability of the bigger one, subtract out the probability of the smaller one, and that will give you the probability of in between. So the probability in between these two numbers here, right here where I did the circle, is 0.2306. Okay, the next one is the same. We want to know the probability that z is in between these two numbers. So let's draw our distribution. And I believe our first is negative 1.57. So here's 0. Negative 1.57 is to the left of 0, so a smaller number. And then 0.23 is going to be somewhere to the right of 0. It's our larger z value. So first, let's find, we know that we're trying to find the probability of it being in between. But first, we're going to find the probability of the smaller one. Zero, 1, 2, 3, 4, 5, 6, 7. 0.0582. Now we're going to find the probability of the larger. 0, 1, 2, 3, 0.5910. So the larger one, all the way up to this, is 0.59. And I'm so bad about forgetting numbers. Okay, that's right. So now take the probability of the bigger z-score and subtract out the probability of the smaller z-score. And that will give you the probability of it being in between. Let me know if you have any questions.